Welcome to the meadow census. At sunset, geese navigate branching physical paths in the grass, and deer make their way through distinctly marked wooden gates. Nature moves in multiple steps, and so does probability. To find the true likelihood of a multi-step event, we must organize the full picture rather than guessing from a single action. Trying to hold every possible combination in your head without a physical system often leads to missed pathways or double counting. To avoid those errors, we rely on one simple rule: make the sample space complete. This fox watches an organized list form for a two-step event, drawing a red or blue berry card and flipping a leaf coin. First, the card options separate into a red row and blue row. Next, we pair each initial card with both coin outcomes, heads and tails. This systematic pairing reveals our entire sample space, 4 distinct compound outcomes. Let's calculate the exact chances of a specific scenario. Here, meadow birds gather around a wooden number cube and a leaf coin. We want to find the probability of rolling an even number on the cube and flipping heads on the coin. Pause the video here. Try to set up the math for these 2 independent steps before we walk through it together. Starting with the number cube, we identify the first independent probability. There are 3 even outcomes, 2, 4, and 6, out of 6 total possibilities. Then we look at the coin. There is exactly 1 heads outcome out of 2 possibilities. For independent compound events, we multiply the stage probabilities together. That means we multiply 3/6 by 1/2. This calculation anchors our physical visual count. The result is a compound probability of 3/12, which simplifies exactly to 1/4. These deer are observing another way to organize outcomes, a natural tree diagram. This model maps the pairings of 2 sandwich choices with 3 drink choices. The first stage physically branches out. We can trace every possible secondary drink choice connected to the first sandwich leaf. To make the sample space complete, we repeat this exact branching for the second initial choice. Mathematically, we have 2 initial branches multiplied by 3 secondary branches. By mapping these physical pathways, we prove there are exactly 6 possible combinations. The tree diagram ensures no pair is overlooked. Whenever you map these multi-step events, anchor your work with a single key phrase. There are blank, equally likely outcomes in the sample space. Finding compound probability is a rigorous mapping process. It relies on complete organization, not an isolated guess. You master probability when you patiently trace, organize, and count every single path the event can take.